Hey guys, Mr. Newton coming at you again, and we're going to talk today about free fall. Now, free fall is one of those super important topics that comes up a lot in physics because, as soon as you find yourself without something underneath you, you fall at a constant rate, 9.8 meters per second squared. And so that's going to happen all the time. And so this is a big, huge deal in physics. A really cool video that you should check out is a video where one of the Apollo astronauts, David Scott, he actually drops a hammer and a feather at the same time. And then another video where they actually suck all of the air out of a room and they drop a bowling ball and a bunch of feathers and they hit the ground at the same time. So the idea is that the acceleration of gravity affects all things equally. And so what is that acceleration of gravity? It's 9.8 meters per second squared. And now really important is that gravity only affects the vertical motion. This is also one that people don't always pick up on, but it only affects the vertical motion. That means if I throw something sideways, gravity's only affecting this. The sideways motion doesn't affect it. It's like it doesn't even exist. A really cool video to watch is Mythbusters, where they actually shoot a bullet out of a gun and they drop a bullet from the same place at the same time. And guess what? They land at the same one. The one shot sideways and the one dropped hit the ground at the same time. And so pretty cool stuff, and it's just almost like mind-blowing. So let me show you guys a couple example problems that you might need to be able to solve with this concept of free fall using the acceleration of gravity, 9.8 meters per second squared. Here we go. I got some awesome tech for you. This right here is some sweet tech. I got this printer, and this printer is amazing. You wouldn't believe it, but as soon as I touch it, it ends up being wired, connected directly to my brain. I mean, this is some pretty crazy tech. It's crazy what they're coming up with these days. So we've got free fall, right? And what is it? It's all based on this dropping at 9.8 meters per second squared. Okay, and so remember, like I said, only affects vertical motion. Only affects vertical motion. Only affects vertical motion, right? Okay, so just the up or down portion of anything flying through the air. Okay, let's do a couple of example problems so that you guys kind of understand a little bit about this. Okay, so I got some cool problems here that I just thought of. All right, so let's imagine that you decide to climb yourself up to the top of a rickety ladder. All right, so you're standing up on top of this rickety ladder, and then you're like, oh, geez, I'm on the top of a rickety ladder. And that's not good. And so you think, okay, what am I going to do? The only thing you know is that this rickety ladder is, let's say it's 9.3 meters tall. Okay, so that's all you know, is that at the top you're exactly 9.3 meters over the top of the ground. And then what you see is you're like, what am I going to do? And so you see a giant ball of cotton candy, kind of like tumbling along like a tumbleweed over here. And you think, oh man, that's a great idea. I'll jump into that cotton candy. But you notice that cotton candy is going 15 meters per second that way. And so, if you jump when the cotton candy is right there, by the time you get down to this bottom of this 9.3 meters, the cotton candy is going to be gone. And so you need to think to yourself, okay, I need to jump when the cotton candy is a certain distance away so I land right on it. Well, how am I going to figure that out? I got to figure out how long I'm going to be in the air. And once I know how long I'm going to be in the air, because gravity is going to pull me down free fall at a constant rate, you see. And so then this will be traveling then during that time. And so if I jump when it's exact distance away for my time in the air to match up to when it arrives right here, well then I'm going to be in good shape. I'm just going to be laughing and giggling and eating cotton candy. All right, so here we go. Let's check this out. So how do I figure this out? What the key information is, how long am I going to be in the air? So 9.3 meters is my displacement. So my displacement final is going to be 9.3 meters. So I got this 9.3 meters. What I'm going to do is I'm going to throw that into this equation, the second equation that I taught you in the previous videos. And I'm going to say, okay, so that equation says, you know, the displacement final equals the displacement initial. Now my displacement initial is going to be 0 because I'm just going from 0 down to 9.3. So that's going to be 0. So displacement initial is 0 plus velocity initial times my time. Now, in this case, oops, I wrote that in the wrong spot. Okay, this is a cool thing. Look at my printer has a backspace on it. All right, so plus velocity initial times time right there. Now, my initial velocity when jumping off here is 0 because, you know, I'm not going anywhere to begin with. So my initial velocity is 0, and then obviously times time, that's not going to matter, so it's going to cancel that out, plus 1/2 acceleration. And so, so plus 1/2 acceleration times time squared. This is the formula I gave you right here. And so what is that? My acceleration, I know, is going to be 9.8 meters per second squared, right? And then I have my time squared right there. All right, so let's go ahead and solve this. So pretty easy to solve once you set this up. You can see that you're going to be dividing 9.3 by 1/2 of 9.8. So let's go ahead and do that. So 9.3 divided by 0.5 times 9.8. And there we go. So we got 1.8. I'll just go ahead and write that out. I'll just round it here, but I'm not ever going to round when I do my calculations as I go because you'll get your answers off. So make sure that you keep your numbers in there. Now, I'm going to go ahead and take the square root of both of these to get it to time. So I'm going to go second square root. I'm going to select that. So notice I used the whole number. I did not round when I was doing my calculations. So my time equals 1.4 seconds. Okay, so 1.4 seconds. So that's how long it's going to take me to fall. All right, so 1.4 seconds, and so I'm going to be falling for 1.4 seconds. I know that. That's my time in the air. That's what gravity is going to do to me right there to fall this exact distance. Well, so how far away, when should I jump to the cotton candy? Well, in 1.4 seconds, how far is that going to travel? So I have 15 meters per second, right? So distance is going to equal my velocity times my time times 1.4 seconds. So let's go ahead and do that. So I'm going to go times 15. Notice once again, I did not round here. I'm not going to round until I have final answers. So I will round this right here when I say 1.4 seconds time in the air, but what I really want to know is how far away, and you'll see right here that that ends up rounding up to 21 meters. So distance equals 21 meters. And so when this cotton candy is exactly 21 meters away, right? When it's 21 meters away, that's when I should jump, because the time in the air is going to make it so that cotton candy is going to be at the exact spot where I need to land on it in 21 minutes. Well, there you go. That's one example problem, and I got a couple of more coming. So if you want some other example problems, stay tuned and watch the next couple installments, because there's some more complicated ones as well, and some different variations that I'm going to throw at you for these free fall problems.